me, Ethel Chamomile, with another tutorial, Unity tutorial. So, last time we already set up our dragon, and in this video I will show you how to make the dragon move, or more like how to make the dragon fall down and jump up, just like in Flappy Bird control. Right, so the easiest way that I can think of to do that is to use something called physics. So Unity has its built-in physics. To apply that, we are going to need a component called rigid body. So we select our dragon and we click here in the inspector tab at component, type rigid, and as you can see we have two options, the just rigid body or rigid body 2D. Since we are making a 2D game, let's select rigid body 2D. So the difference between the just rigid body and rigid body 2D is that, well, as you can guess, rigid body 2D is for 2D physics, while the other one is for 3D physics. Now, after we added that, as you can see, now our dragon has component called rigid body 2D. We have body type, which is dynamic, kinematic, and static. I'll explain that later if we ever gonna use that. And all other options that we won't be covering for now. Since we are going to in Flappy Bird, the character appears to be moving right? But we are going to achieve that effect by actually moving the background, not the character. So that means I want this character to stay here, the dragon to stay in this coordinate, in this X coordinate. And to do that, I will have to constrain freeze position X. That will freeze the X position. So even if the dragon hit anything, it won't, the physics won't affect the x-axis of the position. Now, as for the gravity, is already included in the physics. Now, we already added the rigid body component. Just in case, if you want to remove a component, you can do that by right-clicking the component you want to remove, then click Remove Component. That will remove it. Ctrl Z and it will come back. Alright, now as we can see here in the game, if we play the game, our character will fall down. Very good. But we want to be able to jump, right? Make the dragon some kind of flying. I'll put this here. So for that, we will need a script. But hold up. Before that, we want the dragon to fly when we click the screen, right? And there are several ways to achieve this, but one way that I like is to use a UI. So to do that, we are going to right click here in the hierarchy, select UI and select canvas, right? And select the canvas is where we can put all our UI elements, so like buttons and score display and all that stuff. Now select this canvas, and in the inspector we have to change some settings. Go to the canvas component. I will change the render mode into screen space camera, and then I will select the render camera to be the main camera. To do that, I can click here the little circle icon, click that, go to Scene tab and select the main camera. Now the canvas is just as big as the camera. Why did I do that? Because if it stays here in the overlay, as you can see, if you select canvas and then press F over here, the canvas is actually this big. That's not really a problem, I think. But just to make it simple and easier to work with, I prefer to use the camera here. The plane distance, I will change it to 1 so we can actually see the canvas, kind of. And then here in constant pixel size, the canvas scaler, I want to change the UI scale mode into scale with screen size. That way, the canvas will change its size accordingly to the screen. Because if you don't do that, it will stay at the same size. So for example, if your screen is smaller than for example my current resolution, the UI will get messed up. And as for the reference resolution, I like to make it this 1920 times 1080. And that is all the settings we have to do for our canvas. Now click on the canvas, right click it, select UI and create a button. It seems my Unity has stopped. Hello? There you go. There's a little bit of lag there. Let's rename the button into fly button. Right? If we press F, as you can see here, the button is this. This is the button. And there's a text here that we can barely read, but that's okay. Now, the idea is, whenever we click this button, the dragon will fly up. But we want to be able to click the screen, right? That means we need the button to be as big as the screen. To do that, select the button and look in the inspector tab. Under rect transform component, there's this square thingy. This is called the anchor point, I think. No, it's the anchor presets. Yeah, click that. We will have to select this one so that it stretches along the screen. And see, as you can see now, the little triangles are over here, but the button is still as small as it was. And to resize that to the whole screen, to fit the whole screen, hold Alt and you will change the icons here and click Now the button is as big as the screen. You can also do this by resizing it manually. For example, I change the mode here to rectangle, or you can press T for the shortcut and resize it like so. You can also hold Alt to resize it in all directions like this. Control to resize. I think Control does nothing. And Shift also doesn't do anything. There you go. Shift does this. It's proportional. But to make it easier, I'll just use that. To go back to the arrow thingy, which is the move tool, you can use the shortcut W. Right. Now we have the button fit the whole screen, right? As you can see here in the game view. But there is a text there. We don't want a text. We can just delete the text object under the flyer button, and the text is gone. But now I can't see the dragon. Easy fix. We select the flyer button. Over here we can see the image component. Over here we can see the color. Click the color, and here we can set the alpha. Set it all the way down to 0 and close it. There we go. Now the button stays to be full screen. It's just not at all visible. Right. Now to actually tell the game to make the dragon fly, when we click that button, we will need a script. Let's go back here to the project window. Go to character and then go to character, and I will create a new folder. There's a very loud vehicle outside. I'll create a new folder called scripts. Open the script folder, right click here, create C# script. This here, it's read as C#. I don't know the reason. I will rename it to Dragonfly. Now, when you're naming a script, make sure that you don't use any space. So instead, to differentiate between words, separate it by capital letters. It's also good practice to always start the script with a capital letter, like this. Now, reload. Okay, I'll show you that again. After you create the script, it will stay there, right? You can double click it, and Unity will open what's this called again? Microsoft Visual Studio. It is the currently default script editor. You can change that somewhere, but we'll be using the default for now. It may take some time for the Visual Studio to start, and if it's your first time, you may need to log in or something. I forgot. Anyway, after we open the script, as you can see here, it's like this, right? I'll explain it. First, we have here using system.collections. This, hold up. This is actually, I think, in what called library. I'm not sure. The only thing we need here for now actually is only using Unity engine, because this is where the commands for Unity game Also, we may need this too, but we may also not. We'll see later. As you can see, these two are grayed out while Unity engine stays white. That means this is in use while these two are not. But I'll keep it there just in case. Next we have public class dragonfly. Public means this script, this class can be accessed by other class. I think. Dragonfly is the name of the script. Mono behavior means is the script that Dragonfly is inheriting from. Well, I'll explain about inheritance maybe in later videos, but for now, all you have to know is that mono behavior, if a script has mono behavior here, that means that script can be used as component. Alright, now here we have void start and void update. Void is the return type. So because the return type is void, we don't have to return anything. For example, if I change this to string, it will show an error. Not all code paths return a value. That means I'll have to return a string. For example, ASDF. A string is a word. It's basically a collection of words. Yeah, it's basically like this, right? But if it stays void, then I don't have to return anything. Actually, I can't return anything if it's void. Sorry if that got confusing. Anyway, I'll delete this first. Now, I will have to first access to make the dragonflies. Because we are using rigid body, I'll have to first access the rigid body. I'm going to do this. Public space rigid body 2D and name it RB. Right? Now, as I said before, public means this RB can be called by other scripts. Rigid body 2D is the class type. It's the type, the component that I'm referring to. RB is the name. This whole thing is called a variable, and RB is the name of the variable. But we are currently there are no other scripts that are calling this RB. So to make the game lighter and save memory, actually to save memory and make the game lighter, I will make this private. Hold up, let me show you this. So first of all, we have here public, right? I press Ctrl S to save the script, and we'll go back first to Unity. Wait for it to process the script, and then go to Dragon. Just drag it here, and there we go. As you can see, we have the RB variable here, and we can assign the RB like the rigid body like this, right? Now let's go back here. Thing is, like I said before, there is currently no other script that is calling this RB. So I wanted to make, instead of public, I want it to be private. That means only this script can call RB. This will save memory or something. But the problem is, if I make this private, we can see here in the Unity that RB is gone. So we can't assign anything to it from the inspector. To do that, I will add here, just above this line, I will add, open bracket, serialize the field. There we go. Save it. And as you can see now, the RB appears again. Now I like to, whenever I declare a variable, I like to put a default value of it. So RB is equals null. That means by default, the variable RB is null. There is nothing assigned to it. But since we already assigned it here, it will stay, the value will stay to this. Alright, let's continue. I will also make another variable. The type is going to be float. Float is a number type. I think it's called decimal number. Basically, a number where there is a comma. So, for example, I'll name it first fly force, and the default value is 0f. Let me explain this. Float is basically like for number like 1.4, so like, or like 0.465, this kind of thing, right? Basically numbers with decimals behind it. I want the default value to be 0, and I'll put f here to determine that it is a float. And don't forget to put a semicolon. Is it called a semicolon? I forgot. After that. Alright, so we have here RB and we have here fly force. Let me take some drink first because my throat is dry. I will now make something called function. This function is not being called from other scripts, so I will also call it private. It's not returning anything, so it will be void. And the name, I will give it fly. For function, because this is a function, I'll have to give it this. This is what this bracket right here is where we can put what we call parameter, like string, ABC, and then float something. But I'll explain that later when we're gonna use it. Also, because this is a function and not a variable, I don't need to give it a serialized field, because serialized field only works for variables. Also, because I don't think there's any way to display a function in the inspector. Alright, let's continue. As you can see here, it has red underline, which means it is error. The current fly must declare a body because it is not marked abstract, extern, or partial. That is because we must give it this, a body. Basically, what the function does. Alright, so we have a function called fly. This function fly will be called by other functions. Now, sorry, the mouse is doing the thing again. Well, let's ignore that for now. What I want to do when the function fly is called, I want to make, well, as you can guess, the dragon to fly. To do that, we can call RB, which means we are referencing to here, dot add force. There, add force is a function that is contained in the class rigid body 2D. See, as you can, so this add force function will be public, right? And it returns nothing, so the type is void, the return type is void. And as you can see, there's a red line there, and it also says here, vector2 dot force. It's basically how, that is what we call a parameter, right? So we have to put in that parameter. However, the parameter type is a vector2. That means this fly force has to be a vector2 or not. You can use it like this. I'll give you a simpler example for now. Let's change the float to vector2. Vector2 is basically two floats in the coordinate x and y. So it physically looks like this. This is the x value and this is the y value. Alright. Now there's another way to write this, which is vector2 dot 0. Let's go back here. I'm going to pass the parameter fly force, and then close this with the semicolon, and guess what? We are done. That is all we gotta do. Oh, actually, I'll have to make this public because the fly function will be called by the button that we will press that we just made in the scene view. Let me show you. Don't forget to save the script, and we go back to Unity. Now, as you can see, there's a new field appearing here called fly force. I will give the y value 1000, for example. And the x value will stay at 0. So this basically means the dragon will only fly in the y-axis by 1000 with the power of 1000 whenever we call the fly function. Alright. And that is because in the fly function, we call the add force function from RB. I forgot to mention that add force is basically we tell the physics engine to push an object by this power, by the power that we gave. Right? I hope that is clear enough. Okay, let's go here, the dragon. Alright, here's the fly button that we made before. If you scroll down in the inspector, you can see that there is a button component, and down here you can see on click events, right? Click here on the little plus icon and it will add something. You can drag the dragon object into here and it will change this bar. Drop down menu will change to no function, which we can change by clicking it. We navigate to dragonfly, where the script is the name of the script we want to call, and here we can see the function that we just made called fly. Click that and it's done. Let's save the scene and save the project and play the game. Now as you can see, whenever I click the screen, the dragon flies up. What's happening is actually I'm pressing the button here, and the button calls the fly function. I wonder if I press it. It's gone. Where is my dragon? Yeah, we can't have that. Yeah, basically that. No. But it was too slow, right? We can change that. For example, I want the dragon to fall down faster, so maybe the gravity scale we can make it 3, and the fly force we can make it 3000, or maybe make it stay 1000. We'll see what happens. Play the game and we'll see how it does. What? Yeah, it's still going everywhere. Alright, we can change that. Don't worry, don't worry. Maybe make it something lower, like 250, and this stays at 1. Tum, 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 tum. Yeah, so basically you can change the value, or actually you can just change the value while the game is running. Hold on, let me show you. For example, here we have this, right? So if I pause the game and I change the gravity scale to 1, oh no, the dragon is gone again. Oh, there you go. Come back. Maybe make the drag higher. Make it 10 perhaps. There you go. More like it. Ding, ding, ding. It's a bit slow, huh? Make it 5 maybe. Dum, dum, dum. about that. Maybe make it the gravity 5 so it falls faster. Yeah, I like this. Right. Now, we changed some values here, right? The linear drag is 5, the gravity scale is 5, but if we stop the game, it will revert back to what it was before. Now, here's the thing. For example, I changed this to 5 and this to 1. I think it was 5. Yeah, I think it was 5. I want this. Oops, sorry. Hold on. My voice meter is... Yeah, I haven't donate yet. I want to, but I'll do it later. Alright. I want this to stay, right? So I'm going to right click over here, copy component, stop the game, right click over here again, and paste component by values. As you can see, it changed the value, right? Just like that. When you play the game, the value stays where we wanted it to. Now, I'll show you something else. As you know, the fly force is a vector too, but we are only using the y value, right? So might as well make it float and change this to 1000 as well much we wanted to. But now this throws an error because this is a float. Meanwhile, the parameter that at force function wants is a vector 2. We can fix that by doing this. We will create another local variable here called vector2 dot force, right? Equals to new vector2 0f comma the fly force, and then this will change to force. This, what we just did basically is we created a local variable for this function, so this variable cannot be accessed by other functions, and it only exists in this function. And we created a vector2 with the x being 0 and the y being the fly force. And then we pass the force variable as parameter for the add force. But to make this will... it's not that bad. I think that there's a better way to do this. So what I'm gonna do is I will move the force variable up here. Vector2 force equals vector2 dot 0, and then the force over here we can delete it. What I'm gonna do now is I will assign the force dot y equals to 5 fly force. By declaring the force variable up here instead, it will save up some memory, because if it was down here like before, every time we call the fly function, it will create this variable into the memory and delete the variable from the memory after the function is called. I think that's how it works. But that adds more work to the computer to repeatedly create and removing the force function. But if we declare the function up here instead, the variable is only created once. While down here, we can just assign the y value of force to fly force over and over again. So by doing that, we assign the y to fly force and then pass the force as the parameter for add force. And we can save the script. As we can see here, the fly force field becomes just float, and if you play, it works just the same. There you go. One other thing, when I declared the force here, I didn't use private nor public, right? Because there is no need for that. Or I guess more like it can't be declared like that because it's just a local variable for this function. That's just the reason. Okay, so in conclusion, we have created the click function, the control where if the player taps the screen, the dragon flies up. For now, it can still fly way up here and fall way down over here, but we'll fix that later. So for the next video, I don't know. What should we do for the next video? I think we'll have to fix the collider. Yeah. In the next video, I'll clamp the we will prevent the dragon to go way over here and way over here. That and probably something else. I still don't know. But yeah, that is all for this video. I am sorry that I think it became way too long. Yep, it's 45 minutes, holy crap. Leave a like and subscribe if you like the video, and thank you so much for watching. See you next time. Bye bye.